It's a relationship that puts computers in classrooms and more computer power behind the search for cancer cures. It's a win-win for U of L and the kids of Kentucky. The company that's the linchpin of this collaboration is called DataSeam, and its CEO is Brian Gupton. He's here along with John Trent, professor of medicine, and Wendell Cherry, endowed chair in cancer translational research at U of L. So welcome to both of you.
Good morning.
To see you
Good to
again.
be here.
You're the CEO, right, Brian? And that's your title?
Today.
Today?
Yes.
Last you knew when
Yes.
you walked in the studio?
Yes.
Okay. And John Trent has been with U of L for how long now, John?
17 years.
17 years. Yeah, I knew it.
Actually, I got a promotion. I'm the deputy director now.
Oh, you did?
Of the Cancer Centre.
Okay. So you're a chief cheese, almost a chief cheese?
I do a lot of admin.
You do a lot of bureaucratic stuff?
Yeah.
Is that what you're trying to say?
Yeah.
Well, we'd prefer you spend a lot of your time researching all this cancer.
So would I.
Okay. I know how that works. All right. Well, let's talk a little bit about DataSeam. Brian, why don't you give kind of the synopsis of what DataSeam is for people who have no clue what it is?
Sure, and thank you. So DataSeam is an organization that started as a 10-page paper back in 2003, where we looked at an opportunity to place new computer workstations in the rural parts of eastern and western Kentucky to provide computers to students that wouldn't have them otherwise. Those computers allow them to expand educational opportunities in those school districts. And then even at nights, weekends, holidays, and even when the teachers and students are on those computers, they are providing powerful horsepower for the James Graham Brown Cancer Center to do structure-based drug design, develop new chemotherapy treatments cost-effectively and at a fraction of the time and expense.
So the way this was always described to me is it's like this huge computer network. You take all these computers that you're putting in the school systems, and John Trent over here is using them to do research, right? Is that how that works? Isn't that U of L's role in this whole thing?
Sure, yeah.
So how does that work, John?
So it's a resource that we use, and it doesn't have to be at U of L, but basically for our drug discovery, what we do is we take the structure of a target for cancer, and then we have huge libraries of molecules, 25 million molecules we can buy and test as an anti-cancer agent, but we use the computers to screen first, so it cuts down the expense. You only test 100 instead of thousands, so it's a lot cheaper, and it's a lot faster too, so you can do it in a matter of days. And what we do is we farm out little jobs to all of these computers over the state, over the DataSeam network, and each computer does its work, and then it comes back and gives us the information we need to go and say, yes, we want to test this one against cancer. So in essence, it was a cloud before a cloud.
Right, cloud-based. So it was the idea being that you've got all these computers. How many, Brian, are the computers out in classrooms now? You got 25,000?
Excuse me. There's been a little under 24,000 placed since 2005. We've got a little over 9,000 in schools right now.
Okay.
So, and they all sit on a common network throughout the K-12 system,
Right.
Statewide.
Mostly in eastern and western Kentucky.
Correct.
But in Jefferson County now, too.
Well,
Right? Or getting there.
No, getting there.
That's right.
So yes, mostly in eastern and western Kentucky, and the rural component of this and the funding component, which has made this happen over the last 10 plus years, has been coal severance dollars. So coal severance taxes, which are generated on the mining that's gone on in Kentucky, has funded this as an economic development and diversification program in these school systems to provide opportunities for kids in the sciences and STEM. And that's the one thing we didn't bring up, is that the give back as a part of this program is that not only the University of Louisville, but also Morehead State University, who's our education partner in Eastern Kentucky, they provide 4-year scholarships to these kids to go into STEM and STEM education, which is a very important part of workforce development for the Commonwealth.
So it's a multifaceted thing here. You've got computers in the classroom for kids. You've got scholarships for more kids from Morehead and U of L, right?
Correct.
And they're called DataSeam Scholars.
That's right.
Right. And then you've got John over here taking the computer power from all these computers, these 9,000 computers out in classrooms around the state, and using them to help target cancer drugs, right?
Yeah, and it works. Using this approach, we've had a drug get to the clinic, so it does work.
So this isn't just pie in the sky stuff.
No, it's one of the major resources we have at the Cancer Centre for Drug Discovery, and our goal is to get new drugs into patients. It's not just cure mice.
Okay. We're talking again with Brian Gufton, who's the CEO from DataSeam, along with John Trent, who's a professor of medicine and the deputy director of the Cancer Center at the University of Louisville, the James Grant Brown Cancer Center. So, John, what specifically are you trying to do in cancer research using this computer power from DataSeam? What are some of the specific cancers and cancer drugs that you're trying to come up with?
Okay, so just in the last 6 months last year, without the grid, we would never have done this. There is a protein called telomerase, which is the holy grail, or one of the holy grails in cancer, because it's present in 85% of cancers and not in normal cells. So if you can target it, then there's a good chance you won't have side effects because you're not hitting the normal cells. But there is no FDA-approved drug for telomerase, even though we've known it's been a target for 20 years.
It's been a problem for 20 years.
Yeah.
That we've known.
Yeah, and what we did with the grid, because we had the size of the grid, we targeted a particular gene that's involved in the expression of telomerase, and we know the structure of that gene, and we target it in 18 different ways. So 18 different runs of 25 million compounds, 24 million compounds, thousands of years of CPU we could throw at that. And so it took us 5 years of research to come to the point to use the grid. We used the grid over 6 months. We now have 3 agents that block that protein, and that we're putting into a drug development pipeline. So it works.
So, and it may be a few years, obviously, before that happens, but you're getting there.
Yeah.
You're getting there. Are you optimistic at some point that this thing?
I have to be optimistic. I work in cancer.
I gotcha. And Brian, what's the total amount of dollars that have been plugged into this, plugged into DataSeam and this network and cancer research over the years?
Sure. So
and where are you now?
Okay, fair. The Kentucky General Assembly has invested originally as an economic development grant, and then also they came in after that with a legislative appropriation. So almost a little over $25 million has been invested from the Commonwealth. That $25 million has allowed the Cancer Center, I'll let John talk about the competitiveness for federal grants that the grid allows them to do. But that investment has been made, and we're getting 100% usage out of that investment for the Commonwealth. Right now, we're kind of like everybody else. If anybody follows what's going on in Frankfurt, they're putting together a budget for the next 2 years, and we are a part of those discussions to continue to do what we've been doing since 2005, and also expand the program. Because while we like working with the folks in the coal-producing counties, there's also opportunity to address other rural school districts out in the state to provide them technology. We also have school districts that are no longer producing coal, so we want to keep them in the program as well. And then ultimately the win for the University of Louisville is that they're out recruiting these kids and these bright students to come and pursue STEM careers at the University of Louisville. It's STEM education.
So, John, what would you tell Josephine legislator in Frankfurt, if you got the shot, to say, you're considering all these different budget items, and where does DataSeam and this money for this project fit in terms of cancer research at the University of Louisville and finding a cure for cancer?
The first thing I would say is this is a great opportunity to spend the same dollar 3 times, because it's used in many different ways. Now, as for us as cancer research at the university, it's a critical resource that makes us unique in the country. And when you're competing and only 9% of grants are being funded federally, you need an edge. And this gives us that edge. And it has been responsible for, or as a supporting resource, for over $41 million of federal funding. So it does work. We're unique. If we lose it, we're not unique. We're just another school.
Right.
And we use it to generate preliminary data that we need to put in new grants. So the way the NIH works is, most federal grants work, you need data for feasibility first. You can't just say, I've got a great idea. So we use the grid to generate that data. So it provides the data for us to get the actual research money later. So it's a central resource for us.
Brian, last chance, make the pitch.
Fund it.
That was pretty easy. Okay. Back to you in the studio.
What's wrong with kids' cancer and computers?
Yeah. It's a good program, and so I hope you guys are successful in Frankfurt. And John, I hope you're successful. You've been at the university for 17 years, and so keep up the good fight against cancer, and we'll hope and pray for both of you.
Great.
All right?
Thanks a lot.
All right, thanks, Brian Gupton and John Trent. Brian from DataSeam and John Trent from the James Graham Brown Cancer Center.